So we're in Chapter 8. We're learning about confidence intervals and sample size. Please bear with me as this is the second time I have to rewrite and record this. Our first vocab word from this section is point estimate. The point estimate is going to be a numerical estimate of a parameter. For a point estimate of mu, the best point estimate we could have is x bar. So the best estimate of a population mean is going to be the sample mean. If we think about finding out the average age of a student at Colebrook Academy, we're thinking about the fact that we have students from the age of 13 for some cases, all the way up until 19 or 20 in other cases. So if we're looking at that age range there, and I say, if I selected one person, what would be the estimate of that person? Well, we could take the population mean, and that would take adding up a whole bunch of numbers and figuring it out. Or we could take a smaller portion, a sample of that portion, and find out the mean of that sample. So in our case, we have about 100 students. Taking a sample size of 10 might be good. If I pick 10 people at random and find the mean of their ages, we'll probably have a good estimate or a good point estimate of our parameter. We could also look at an interval estimate. The interval estimate is an interval or range of values used to estimate the parameter. You know, in English, when they never told you to don't use the word to define the word, well, statistics is proving you wrong, so we have interval and estimate both in this definition. But anyhow, when we're looking at the students of Colebrook Academy and looking for their ages, we could come up to say, well, the students are between, or the mean is between 13 years old. I'm not going to use x there, sorry, I'm going to use mu. So the range is between 13 years old and 20 years old. Okay. This interval here is a pretty wide interval. It has almost everybody who would attend Colebrook Academy. We might have some students older than 20. We might have some students younger than 13. I don't know right now if we've had anyone younger than 13, but I'm pretty sure we've had some that are older than 20. We could also write this as, no, that's not what I wanted to do, as 13 and 20 together gives us 7, so 4, we'll go with between, we'll say 17, 16.5, plus or minus 3.5 years old. So that means it go from 16.5 all the way up to 20 down to 13. Those are two different ways we can write this interval. It should also be noticed that in the interval estimate, our parameter may or may not be within the interval. When we want to talk about making sure that our parameter is in between the interval there, we're talking about our confidence interval. Now our confidence interval is usually about 95%. There's a 95% chance that my estimate of an age of random person I select from Colebrook Academy is going to be between these two numbers here. Currently, I don't believe we have anyone older than 20, and we don't have anybody less than 13, so this would be true. If I ignore this over here real quick, if I wanted to have an interval that is 99% instead of 95%, which my confidence interval is going up, I need to look at erasing everything before I start recording. So instead of having a 95% confidence interval, if I'm looking for, now my pen doesn't work. So if I'm looking at this with my 95% confidence interval, and I need to look at a 99% confidence interval, I need to widen my interval. So instead of having between 13 and 20 years old, I might switch it between 10 and 22 years old, where we could have a student who is close to 22 or 10, and then my mean would definitely be between here. My parameter would definitely be between these two numbers. So we have the confidence level, which is the probability that the interval contains the parameter. We also have the confidence interval, which is a specific interval estimate of the parameter determined by using data obtained from a sample by using the specific confidence level of the estimate. Three common confidence intervals that we'll be using are the 90%, 95%, and 99% confidence intervals. Remembering that the higher the percentage of confidence, the wider the range of numbers will be. The least precise ones, the more narrow it will be. So the formula for the confidence interval of the mean for specific alpha is written as x bar minus z sub alpha divided by 2 times sigma divided by the square root of n, remembering that sigma is your population standard deviation divided by the square root of n, your sample size, gives you your sample standard deviation, is less than mu, is less than x bar minus z, that's supposed to say plus z, sub alpha over 2 times sigma over the square root of n. Now for our z values, when we're looking at 95%, the z value of alpha over 2, we're looking at, ready for my sad attempt at a drawing. Hold on a second, let me draw first. Here we go, that drawing's not too bad. So remember when we're looking for 95% of our standard normal distribution here, if mu is the middle, we're looking at looking at 95% being from here to here, and then we have 5% hanging off down at the ends. Now our number alpha is going to be what's left over here at the ends in our tails. If we have 95% in the gray area, how much is left here? We have 5%. So we know that we have to take our 5% and divide it by 2 to split it between the two tails. So that is why we have alpha divided by 2 here. So we're looking at our z value for alpha divided by 2, which is the end tails here. So for 95%, we get 1.96 as our z value, and at 99%, we get 2.58. So that is our standard deviations away from the mean that we're going to be looking at. So for assigning pieces to each of these parts here, we know that we have mu, which is our center line here, and we know that z sub alpha over 2 times sigma divided by the square root of n is going to be this section, and it's also going to be this section here. It's the percent underneath the curve, which will add up to the 95% we're looking for. So let's calculate a confidence interval. A certain medication is known to increase the pulse rate of its users. The standard deviation pulse rate is known to be 5 beats per minute. A sample of 30 users had an average pulse rate of 104 beats per minute. Find the 99% confidence interval of the true mean. Since we're looking at a 99% confidence interval, we know that we're looking at z sub alpha over 2 to be equal to 2.58. So we can substitute into the formula. We have x bar, which is our sample mean, which was 104, minus 2.58 times our standard deviation of the population, which was 5 beats per minute, divided by the square root of our sample size, which is 30 in this case. And that our mean will be between that and 104 plus the same thing. Our z sub alpha over 2 times 5 over square root 30. And we calculate this and find that we have 104 minus 2.4 is less than mu is less than 104 plus 2.4. We add this together, we get 106. Nope, lies, that's subtraction. 101.6 is less than mu is less than 106.4. So our confidence interval can be written like this, or it could be written as, hold on one second, rounded we get 102 is less than mu is less than 106, or 104 plus or minus 2 beats per minute, of course. This is all I could probably fit into this video. So you may have just this one video, or I might create another video. I'm not sure. Either way, you're not going to do it until Monday night.